So just a quick thought experiment then. Let's have a look at a right angled triangle which actually has some lengths on. Okay, so use this theory. Let's look at a right angled triangle which has some lengths on. In fact, let me make this a little bit bigger. Okay, let's suppose that this is the angle which I'm looking at. This is the angle which I'm interested in. And I'm going to say that that angle there is 30 degrees. Okay, so 30 degrees. All right, let's suppose that this angle is, this side is 4, okay? And I'm interested in finding this side over here, So, let's first of all label up our sides. So what would this side be called if it's in relation to this angle? The opposite, good. What would this side be called if it's in relation, well, what would that side be called? It's always the hypotenuse, right? Because it's the side opposite the right angle. Good. So which of these ratios would I be looking at if I want to compare the opposite and the hypotenuse? It's sine, right? Because that's the one which compares the opposite and the hypotenuse. So what I would say is that sine of my angle, what's my angle in this case? Good. Should be equal to the comparison of my opposite and hypotenuse. Well, my opposite I don't know. My opposite is x. My hypotenuse I do know, it's 4. So let's come back to this. Could somebody stick in their calculator sine of 30? So the sine button should be on the left-hand side of your calculator. So it should be on the right-hand side of your calculator. So simply type sine and 30. Not quite.
0.6427. It's all over 2.
It's a half, isn't it? It's a half, right? So you're basically saying, if you stick sine of 30 in a calculator, this comes out as a half, okay? Now think about this. Let's think about it in terms of ratios. That literally says that if you compare the opposite and the hypotenuse, it should come out as a half. In other words, the opposite should be half as big as the hypotenuse, okay? So if the hypotenuse is 4, what should the opposite be? It should be 2. Okay, so x in this case should be 2. But you don't necessarily have to do that. Because if you think about it just purely in terms of this, exactly, if you think about it purely in terms of this, as an equation, on this side you've got a half, on this side you've got x over 4. So to find x, you would just have to multiply by 4 on both sides. So half of 4 is also 2. Does that make sense? Yeah? Okay, so last little bit from me, and then I'll let you loose on, well, actually no, then we'll take a break. This is useful, okay? This is how we get the idea. But because there's 3 things going on, we can either have the sine of an angle, we can have a side, and we can have another side as well. So in this case, sine of an angle, the opposite and the hypotenuse, or cos of an angle, adjacent hypotenuse, and the same for tan. I think it would make sense to write this as a triangle, a formula triangle, okay? So in other words, I'm going to set up a triangle like this. Now, are we all familiar with working with formula triangles? So we cover the thing up which we want to find, and then we just work out what we need to do for the others. So in this case, I've got S, I've got O, and I've got H. So I'd say that there would be SO, okay, SOH. What would this formula triangle be? So what would go in the bottom left? Yep. What would go here? What would go here? H. Can you see how we get that from there? Okay. And then what would go in the bottom one? So what would go here? T. Good, exactly. Now some of you probably have heard this as so, ka, and toa. So, ka, toa. Okay. The so, you can see here, the S corresponds to sine of my angle. The O corresponds to the opposite, and the H corresponds to the hypotenuse. This one down here, the C corresponds to the cos, that's the adjacent, and that's the hypotenuse. And this one down here, the T corresponds to tan, the O corresponds to opposite, and the A corresponds to the adjacent. Okay? So how does that work then? So let's use it over here. So in other words, I would cover up the thing which I want to find. So in this triangle over here, would you be happy, first of all, what am I not interested in?
What am I not interested in?
Mm-hmm.
The adjacent.
The adjacent. Like, the adjacent I'm not interested in finding, and I haven't been given any information about it. So I'm not interested in the adjacent. So anything with an A in gets ruled out. Well, that's got an A in, so I can't use that one. That's got an A in, so I can't use that one. Therefore, it has to be that one. Would you be happy? So this is my formula triangle. That's my SOP. Okay. Now I think, what do I want to find? What do I want to find in this triangle?
Want to find the x.
I want to find the x, which in this case is the opposite. Okay. So I'd come along and I'd cover the O up. Okay. So I want to find O, so that leaves me with S and H. How would I combine together the S and the H? Good, because it's on the bottom, so I'd times them together. So I'd say, okay, O would be equal to S times by H. So I'd write that down first of all, then I'd fill in what I know. So in this case, my O is called X, my opposite is called X. My S is short for what?
Sine 30.
Good, it's sine, it's always of the angle. Good, so it's sine of 30. Okay. And my H is equal to 4. And if you stick that in your calculator, literally type it in, it should come out as 2 as well. Does that make sense how we use those? Any questions about that?